Hello students. So in this video we will be looking at your PYQs of work power energy, right? Let us start. So the first question that we have is, that is your NEET 23 question. It says the potential energy of a long spring when stretched by 2 centimeter is U. If the spring is stretched by 8 centimeter, the potential energy stored in it is. Okay. So when displacement is your 2 centimeter, when x is equals to 2 centimeter, potential energy is U. When x is 8 centimeter, what is your potential energy? I am calling it as U dash. This is what they are asking. What is potential energy of spring? U is equals to half k x square. So from the first situation we can say U is equals to 1 by 2 k 2 centimeter square first. U dash for 8 centimeter we can write U dash is equals to 1 by 2 k 8 centimeter square. Equation number 2. Now we have to find out U dash in terms of U. So 2 by 1, we do 2 by 1, we will get U dash by U is equals to half k cancels out. We are left with 8 by 2 whole square. This is your 4, 4 square will be your 16. So U dash will be 16U. U dash is 16U. Our answer is D option. Next question says the energy that will be ideally radiated by a 100 kilowatt transmitter in 1 hour is. So the power of transmitter is 100 kilowatt. They are asking us energy in 1 hour, right? Let us see. What is our energy in term from power? What can we write down? Energy is basically power into time. Energy is power into time. In terms of power we can write. Power is given to us 100 kilowatt. 100 kilo will be 10 power 3 into time. Time is in hour. So if we change it into second, it will be your 3600 second. Everything is in SI unit, right? So we'll get our answer of energy in joule. How much are we getting it? 36, 2, 3, 5, 5 to 7. 36 into 10 power 7 joule. 36 into 10 power 7 joule, which is your option number 4, last option. Yeah. So the third question that we have is, it says an electric lift with a maximum load of 2000 kg lift plus passengers. So let's consider lifts and passengers. Total mass is given to us as 2000 kg. This is the maximum capacity, for passengers plus lift. 2000 kg mass. Okay. Moving up with a constant speed of 1.5 meter per second. V is 1.5 meter per second. The frictional force opposing the motion is 3000 Newton. So during its motion, some frictional force is acting, which is given as your 3000 Newton. Next, the minimum power delivered by the motor to the lift in watt is. Okay. So power they are asking us. Friction is acting downward, as well as your this, due to this whole mass, mg will act downward. Mg, how much will be mg? Mass is 2000 and g is 10, so it will be your 20,000, right? 20,000 is your mg, right? And this is your friction. I have shown it over here, 3000 Newton. Now tension will be pulling this whole lift upwards. So they are asking us how much power is required by the motor. So power delivered by the motor. Power we know is given as basically force into velocity. Power is force into velocity. Over here velocity is given to us, it is 1.5 meter per second. So power is instantaneous power, power is work done by time, and we can also write instantaneous power as force into velocity. Velocity is constant, so instantaneous power, or we can calculate this. Now force, how much is upward force which is required to move this whole system over here? So upward, what it will be, minimum force required will be, tension must be minimum equals to your 3000 plus 20,000. So tension will be equals to 20,000 plus 3000, which is 23,000 Newton. This much amount of tension is required to lift to move the lift upward. So force is 23,000 and velocity is 1.5, that is your 3 by 2. When you will solve it, your answer will come out 34,500 watt, right? Which is option number B. Second option is a correct answer. Next, the question that we have is, it says a gravitational field is present in region. A point mass is shifted from A to B along different paths. So different paths are shown to you. This is some path A, this is your path 2, this is then your path 3, 1, 2 and 3, right? They are asking us is shifted from A to B along different paths shown in the figure. If W1, W2, W3 represents the work done by gravitational force for respective path, then now which one will be more along which path? Now work done by gravitational force. What is the nature of gravitational force? Gravitational force is conservative. Gravitational force is conservative, right? If gravitational force is conservative, that means the work done is path independent. Work done path independent. It is path independent. Initial point A, final point B, in all the three cases is same. Therefore, work done in first path will be equals to work done in second path, which will be equals to work done in third part. Reason being, gravitational force is a conservative force. So in gravitational field, whatever work will be done, that will be path independent. It will be same for, if initial and final position are same, work done will be same. Okay. Yeah. Next, we have a graph question. The restoring force of a spring with a block attached to the free end of a spring is represented by. They are asking us your graph between force of spring and X. What is our spring force? Force of spring is given as minus Kx. And force of spring is minus Kx. So if we plot the graph, this on the y-axis, this on the x-axis, this is on the x-axis, this is the displacement or position which is on the x-axis. So if we plot a graph, obviously it's a straight line, obviously it's a linear relation and it's a straight line. And next, if you notice the slope over here, is negative. The slope is negative. At x equals to 0, force will also be 0. So it will pass through origin, it will be straight line and the slope is negative. That implies your graph will be coming something like this. Which option do we have? Option number 4. Either first or fourth, because there are only two straight lines, it's a linear relation. So first or fourth. In first and fourth, how do we decide? In first, the slope is positive, whereas for our force F equals to minus Kx minus the slope is negative. Slope should be negative, therefore it should be your fourth will be the correct answer. Yeah. So the question that is given to us is, a particle is released from height s from the surface of earth. So let's consider a particle is released from a height of s from the surface of earth. At a certain height, its kinetic energy is 3 times its potential energy. So initially, if it is released over here, speed initial release, that means speed will be 0, kinetic energy will be 0. It will only have potential energy. And when it falls down, the kinetic energy will start increasing and potential energy will start decreasing. At some point, its kinetic energy becomes 3 times potential energy. Let's say that at this point the height from ground is x. We are considering that at this point the height from ground is x. Next, it says the height from the surface of earth, that means they are asking us x, the speed of the particle at that instant r. Okay, now this question you can do by kinematics also. first you calculate the speed and then you put your half mv square, all that, or directly we will use our mechanical energy conservation. As we know that whenever under motion under gravity, in motion under gravity only mg force is acting, mg is conservative, mechanical energy is conserved, right? Mechanical energy is conserved. So let's say that this is our A position, this is our B position. What can we write? Mechanical energy conservation. So mechanical energy conservation, K initial plus U initial equals to K final plus U final, right? In this whole journey, the mechanical energy will remain conserved. So two positions we have considered, position A, which is our initial position, position B, which is our final position. So initial position, kinetic energy 0, potential energy, height is S, so it will be mg into S, mgh, and in the case over here they have given us height as S, is equals to final kinetic energy. Over here at a distance of x, kinetic energy is 3 times potential energy. So I can write 3 times mgx, x is the height of this B point, plus potential energy, which will be your mg into x. If we solve it, we get mgs is equals to 3 mgx plus mgx, 4 mgx, mg cancel, x value comes out to be s by 4. So the height is s by 4, we got it. Okay, do we have option? Okay, 1, 2, 4, 3 options are s by 4. We need to find out the speed also. How do we find out speed? Over here they have mentioned that your at this point x height, kinetic energy is 3 times potential energy. We will use this relation only to find out speed. Kinetic energy is 3 times potential energy, kinetic energy is half mv square, 3 times potential energy, mg into x. Now x value we have found out, this is your s by 4. So from this m and m cancels out, v square value will be 3gs by 2. V square value comes out 3gs by 2. So v value will be root over 3gs by 2. This will be our answer. Which option do we have? Option number 4. Option number 4 is our correct answer. Yeah, so our question says water falls from a height of 60 meter at the rate of 15 kg per second. Okay, so water is falling from a height of 60 meter and it is 15 kg per second. This is the rate at which it is coming. Now they are saying the losses due to frictional forces are 10% of the energy. That means how much will be the energy possessed by your 1 kg? If we have to write down, it will be, or energy possessed by water will be mgh at this height. This energy is being used by the turbines. How much is being used? 90%, because 10% is being lost into the friction. So power we can write at, they are asking us how much power is generated by the turbine. So power we can write, power will be your energy which is available per unit time. How much is the energy available? 90% of the energy, 90% of the potential energy is available. So 90% of mgh. And this is mass is per second. So we will get over here 1 second over here. This is 1 per second. Fine. So ultimately our answer will come in watt only. Let us see. 9 by 10 is into mass is your 15 kg per second into h, height is 60. 10 10 cancels out, 15 into 9 into 6, it will come out to be 8100 watt. It will come out to be 8100 watt. Which option do we have? Options are given in kilowatt. If you see this one we can write it as your 8.1 kilowatt, right? Let us move ahead. Yeah, so the question given to us is a force F equals to 20 plus 10y acts on particle in y direction where F in Newton and y in meter. Work done by this force to move particle from y equals to 0 to y equals to 1 meter is. They are asking us work done. when the position changes from y, work done when position changes from y equals to 0 to y equals to 1 meter. Now, work done, we have to calculate force is given to us. This force is not a constant force. This force is varying with position with y, right? And how do we write down work done by variable force? Work done is given as integral f dx. Generally, this is the relation that we people keep in our mind. Integral f dx, right? Where when f is variable, it varies with x. We write it like this. But over here, force is not a function of x. Force is a function of y, right? So our work done in this case we will write is integral of f dy, right? Work done will be, because displacement is also happening in y direction. Now let us see, work done will be equals to force is 20 plus 10y dy. Limits are y equals to 0 to y equals to 1. Now work done we can write as, if we integrate this, it will come out to be 20y plus 10y square by 2. Limits are from 0 to 1. If we substitute the limit, we get it over here. 20 plus this will be your 5. So 5 into 1 square. So 20 plus 5, that is your 25 joule. 25 joule is our correct answer. Option number A. Yeah. So our question is, it says, consider a drop of rainwater having mass 1 gram, fine, having mass 1 gram, falling from a height of 1 kilometer. So this height is 1 kilometer. If it hits the ground with a speed of 50 meter per second, when it reaches over here, speed becomes 50 meter per second. Then work done by gravitational force and resistance force of air is G, take as 10 meter per second square. How to do it? Now work done by gravitation we can calculate directly. Do we know gravitational force? Yes, which is mg, we know it. Do we know displacement? Yes, displacement is 1 kilometer. So work done by gravity we can directly write as Fs cos theta. Force is m into g, displacement is 1 kilometer, and angle between them is 0, because mg downward, displacement downward, so cos 0 it will be your 1. So if I substitute over here 1 gram, that is 1 by 1000, into g 10 into 1 kilometer, that will be your again 1000, cancels out. Work done by gravity comes out to be 10 joule. 10 joule is your work done by gravity coming. Now to find out work done by air resistance, when this air drop will be moving downward, your force of air will be acting. That means air resistance is always opposing force. So air resistance force will be upward. How do we calculate? So for that we will use work energy theorem. We will be using work energy theorem. What does our work energy theorem give us? Work done by all forces is equals to delta K. Which all forces are doing work? Gravity is doing work and resistance force is doing work. So we can write work done by gravity force plus work done by air resistance is equals to K final minus K initial. Over here, work done by gravity, we calculated 10 plus work done by air is equals to kinetic energy final. Final kinetic energy, speed is given to us 50 meter per second. So we can write 1 by 2 into m, that is 1 by 1000 into v square. 50 square will be your 2500 minus initial kinetic energy is 0, because considering it starts from rest, it is released only, basically air drop, sorry, water molecule, no one is throwing it, it is released. So initial speed 0. Now what we are getting over here, 0 cancels out. So work 10 plus work done by air is equals to, this will be your 25 by 10, 25 by 20, which we can write as 5 times 4 times. So work done by air will be 5 by 4 minus 10. When we will solve it, our answer will come out minus 8.75 joule. Right, work done by air will come out to be minus 8.75 joule, which is your option number C. Option number C will be our correct answer. So Our next question is, it says, one end of a string of length L is connected to a particle of mass m and other end is connected to a small peg of a on a smooth horizontal table. Fine. So let us draw the situation. Horizontal table, and what you have is this side particle m. So it's a horizontal motion is taking place basically. Over here horizontal motion will take place. The motion will happen in horizontal plane. Fine. If the particle moves in circle with speed v, the net force on the particle is directed towards center will be T plus mv square by r, T minus mv square by L, 0 T. So this is a question from your circular motion. What do we know? Force centripetal. What is a force centripetal? Force centripetal is mv square by r. R in this case will be L. Now which force is acting over here? Which force is providing the necessary centripetal force? Over here, because the mass is connected with a string, that means tension will be acting. Tension will be acting towards the center. So force centripetal is equals to T only. Force centripetal is equals to T, which is equals to mv square by L. So our force, net force acting towards the center is your tension T only. There is no other force acting towards the center, right? Fine. So our option will be your D option. Okay, so this is our last question of the video. Let us see what it says. A body of mass 1 kg begins to move under the action of a time dependent force. Force vector F vector is given to us 2t I cap plus 3t square j cap. 2t I cap plus 3t square j cap. This is force as a function of time t given to us. Okay, what power will be developed by the force at the time t? At the time t, what power will be developed? Right, let us see. So power we know is instantaneous power is given as force into velocity. That is your dot product of force and velocity. We know force as a function of time t. Can we calculate velocity as a function of time t? Yes. Mass is given to us 1 kg, right? So first of all, force we know, mass we know, we can find out the acceleration. Acceleration will be force by mass. Acceleration will be force by mass. How much it will be? Mass is 1 kg, so acceleration also will be same only, 2t I cap plus 3t square j cap. Now acceleration, what is our acceleration? Acceleration is dv by dt. So dv by dt is equals to 2t I cap plus 3t square j cap. Over here I'll arrange it. dv is equals to 2t I cap plus 3t square j cap into dt, right? We'll integrate it and find out our velocity. So if we integrate it, let us see, this will be your v. Integration of this will be 2t square by 2i cap plus 3t cube by 3j cap, right? Which we get velocity as a function of time t, t square I cap plus t cube j cap. This is our velocity as a function of time t, right? Let us write down power. Is it space is there? Yes. So force is this, power will be F dot V, power will be F dot V, F is 2t I cap plus 3t square j cap, and velocity we calculated by integrating our acceleration, which comes out to be dot t square I cap plus t cube j cap. Visible, fine. I hope this is okay. So force and velocity we got it. Time function, we'll do the dot product. Dot product, what we do? Coefficient of I, coefficient of J, coefficient of K. There is no K over here, so we just need to multiply coefficient of I and J. So coefficient of I, if we do it, it will become 2tq plus 3t power 5, t square t cube. This will be, so this will be your power coming 2t cube plus 3t power 5. Which option do we have? Option 2t cube plus 3t power 5. Option number B. Option number second option is our correct answer. B option, second option is our correct answer, right? So with this, we have discussed the questions of your 2016 to 2023. Some vector question or something are there. I hope you can do those, है ना? That mostly we have discussed over here. All are questions related to your work, energy and power. Fine. So with this we have done our video. I hope you found the video helpful. If you liked it, do consider to press the like button and subscribe to our channel. Thank you very much. Bye bye.